Okay, there we go. I don't know what happened. Okay, so section 8.3, part 3 is on the shell method. All right, the shell method is not supposed to be on the AP AB exam. Okay, but I have seen it show up in multiple choice questions where the setup is using that 2 pi r times f of x. So sometimes they will pop up on the multiple choice, but it's very, very rare. So the convenience of knowing the shell method is if you can't solve it with the disk method or the washer method or whatever, you can use the shell method. So it's nice to know both methods. This one can be a little bit faster sometimes. Okay, so this says sometimes volumes are very difficult to solve using disk and washer methods. For instance, suppose we have the region R bounded by 2x squared minus x cubed and y equals 0. All right, so we have this region right here. We're going to call it R. And we're asked to find the volume of the solid obtained by rotating R about the y-axis. So we're going to go around this axis. Can you guys visualize what shape is created? Those of you that bake might call it a bundt cake. Right, it looks like a bundt cake. All right. So if we are going to use the washer method, guys, if we're going to use the washer method, we need an outer radius and an inner radius. So think about your outer radius and inner radius. Here's the outer radius. Here's the inner radius. What's wrong with this situation? It's the same curve. I mean, you would somehow have to break that curve into 2 separate pieces. Since we're integrating around a vertical, or since we're rotating around a vertical axis, we need to integrate with respect to y, right? So we need to solve for x, and that's going to be really hard to solve for x. Y equals 2x squared minus x cubed. I don't know how to do that. So we learned this other method. We learned the shell method, which makes it easier. Okay, let's say we have something else, like figure 2. Do we have something else in figure 2? So Q is going to be the region formed by y equals 4 minus x squared and y equals 0. So let's write an equation to find the volume of the solid form when Q is rotated around the line x equals 3. All right, so this is Q. And we're going to rotate around x equals 3. So again, it's a vertical axis. Okay, this one wouldn't be so bad. We need our outer radius and our inner radius. We need to integrate with respect to y. So in our case, we had y equals 4 minus x squared, so we need to solve for x. So when we do that, we have y minus 4 equals negative x squared. Divide by the negative, so it becomes 4 minus y, right? Negative y plus 4 equals x squared. So when we take the square root, we get x equals plus or minus the square root of 4 minus y. That's what's breaking it into the 2 pieces. Okay, so this side that I'm drawing in green, those x values are negative. It's x equals negative square root of 4 minus y. And the side I'm drawing in red is x equals positive square root of 4 minus y. So that allows you to use your outer radius and inner radius. Okay, so you could do it in an example like this. Okay, so let's go ahead and set it up. So my volume is going to be pi. My y values go from 0 to 4. I'm going to have my outer radius squared minus my inner radius squared. So outer radius is the negative number, so negative square root of 4 minus y squared minus my inner radius squared. So this is 0 to 4. Negative squared becomes positive. Square root squared becomes 4 minus y minus 4 minus y. I did something wrong. I think I need absolute values. Gotta think about it. 4 minus y. I think I do need absolute values. Remember how if you have square root of x, squared, it equals the absolute value of x, like that. So let's go ahead and we'll do math 9 just like it is, so we can avoid doing the absolute values and everything. Oh, guys, I made a very simple mistake. What did I leave out? No, go back. I'm not going around the y-axis. I'm going around x equals 3. Or y, yeah, x equals 3. So I need 3 minus each of those. So it needs to be 3 minus, the outer radius was the negative, so plus square root of 4 minus y squared minus 3 minus the square root of 4 minus y squared. Okay, and this one we would have to use math 9, unless you want to FOIL it all out and everything. All right, so I have 3 plus square root of 4 minus x squared. Are you guys trying the setup? This is a good one to try on your calculator on your own to see if you get it. Mine's thinking a lot as you're thinking a lot. All right, and mine ends up doing a little bit of a calculation error. I got 64.000000032. So this is a calculator rounding error. So it's adding up all these different heights, right? When you integrate, you're adding up all the different heights of your rectangles, and it's messing up somewhere. I mean, it's doing a little rounding error. So it is 64. So it's 64 pi. Okay, so it says this would be somewhat tricky to integrate, but we could do it. You could use a U substitution. You could FOIL your terms out. But the setup really wasn't very nice. Okay, notice we had to solve in terms of y. If we can somehow avoid that solving so that we can use y values and instead can use x values, it will be a lot easier. Okay, so that's what the shell method allows us to do. It allows us to use that 4 minus x squared instead of solving for the x, right? Okay, so this is what gets confusing though, because then people get confused on, remember I told you if you had a vertical axis you wanted y values, if you had a horizontal axis you want x values. It's the opposite for the shell method. Okay, so it gets kind of confusing. So make sure you have them straight. You might want to do some flashcards. All right, so I'm not going to go through this whole method of cylindrical shells. I showed you the little wood pieces that look like little cylinders, one around the other. So these are shells. So it just gets bigger and bigger. So we're using like cylinder shells. Okay, so our formula is right here. So it's from A to B, it's 2 pi radius times height. And you integrate it. Okay, the key to the shell method, so notice how I wrote it here, is to draw a vertical rectangle if you go around a vertical axis, and draw a horizontal rectangle if you go around a horizontal axis. Okay, again, this is different than our disk method, which gets confusing because if you remember, if we had some kind of curve, say I had that, and I was going around the y-axis, we were taking an outer radius. So we're taking a radius, which was a horizontal line. Now we're going to do vertical lines because we're going to take that vertical line, so like this right here, and we're going to swing it around the axis and create a shell. Okay, so that's what we're doing. Are they okay? Yeah. All right, so find the volume of the solid of revolution formed by revolving the region bounded by x equals 4y minus y cubed and x equals 0 around the x-axis. This might be one of your homework problems. All right, so 4y minus y cubed. So that's this. We're doing the region that's bounded by this curve and the x-axis. So here's our region. We're going to go around the x-axis. So we're getting that like bundt cake shape. Really tall bundt cake. I have trouble saying bundt. Bundt.
That would make it like.
So think about what shells are being created. As you're going around, think about shells. What do the shells look like? So where are my cylinders? What do they look like? They're sideways, right? So you're taking this rectangle right here, any rectangle, and you're rotating it around this axis really fast, and you're creating a cylinder. So we need to talk about the height of the rectangle and the distance that the rectangle is away from the axis. That's called our radius. So the distance, so radius is distance that the rectangle is from the axis of rotation. You can put your rectangle wherever you want. And then the height is just the height of whatever your rectangle is. Okay. It's what? Length of the rectangle. So height is the height of the rectangle. In this case, length if it's on the side. Okay. So the radius can, or this rectangle can be wherever I want to place it. Okay, my radius is y. Do you guys understand that? Wherever I'm going to place, it's going to be at a particular height. Okay, my height depends on where y is. What's my height? Your equation, 4y squared minus y cubed. You could also say minus 0, right? Right minus left, like we've done before. Does that make sense? Right minus left. But our left in this case is the y-axis, so it's 0. Okay, so our height is 4y squared minus y cubed. So always think it's the opposite of my disc and washer method. So since I'm going around the x-axis, I'm not using x's. Instead, I'm using y's. So you're using y's. So your volume is always 2 pi r times height. So 2 pi can go on the outside. My radius is y. My height is 4y squared minus y cubed. Oops. Y values go from 0 to, I don't know, what's it go to? I think it's 4. See if you plug in 0, let's see, so plug in 0 for x. So 0 equals 4y squared minus y cubed. You'd pull out a y squared, 4 minus y, so it's 4 is your y value. Solve it out. So 2 pi, 0 to 4, 4y cubed minus y to the 4th dy. So I'm going to have y to the 4th minus y to the 5th over 5, going from 0 to 4. Four to the 4th is 256 minus 4 to the 5th divided by 5, so 204.8. Oops. So you end up with 512 over 5 pi. That's your answer. Okay, so pretty straightforward. You guys understand? Like I said, the most confusing thing is that it's the opposite of the disc method. I mean, instead of using x values, you're using y values. You know, you have to think about what that rectangle looks like. Okay, so let's try another one. Okay, so find the volume of the solid revolution formed by revolving the region bounded by y equals 3 plus 2x minus x squared and x plus y equals 3. So I've drawn those in for you. So here's our region. And we're going to go around the y-axis. So think, If I was using disk method, I would use y values. So with shell method, use x values. Okay. I also think if I'm using the shell method, I'm going to draw in, since it's a vertical axis, I'm going to draw in a vertical rectangle. So some kind of rectangle in there. And like I said, it doesn't matter where that rectangle is. I mean, it could be over here. It doesn't matter, just as long as it's between the top curve and the bottom curve. Okay, so say we take this vertical rectangle and we swing it around the y-axis. Do you see the shells that are being created? You can visualize it? Okay. All right, so our radius is the distance to that rectangle, x, right? Your height of the rectangle, how do I do that? Top minus bottom. So I want both solved for y, so in this case we're good. This one is y equals 3 minus x. So I'm going to have 3 plus 2x minus x squared. That's my top. Minus the bottom was the line 3 minus x. You can simplify, so 3 minus 3, the 3's would go away. I'm going to have my negative x squared. I have 2x. It ends up being plus x, so plus 3x. That's my height. So my shell method is 2 pi. My radius is x. When would it not be x or y? When you're not going around the x or y axis. So think if it was over here. Think if we were going around x equals negative 2. How would I then find the radius? Like that distance to my rectangle. 2 plus x? You could do that. Yeah, I usually do right minus left, so I do x minus a negative 2, right? So x minus negative 2, just like we did in the last things. Okay, so keep that in mind. So we're going to get to things like that. All right, and then your height is negative x squared plus 3x dx. X values are going from 0 to, looks like 3. Makes sense because that's where this one's crossing the x-axis. And they meet at that point. All right, we'll math 9 it. All right, x, negative x. Did you guys get an answer? Okay, I got 27 over 2 pi. Did you guys get that? Okay. Okay, so you guys try number 3. So see if you can get it on your own. So drawing a rectangle.
When it's a clear argument, what is that?
All right, so notice how it gives you a domain. It says between 0 and 1, so you're only taking this region here. And that's what you guys were asking about. Some of you thought from negative 1 to 1. If it was from negative 1 to 1, that would create like a donut shape. Not quite a donut. Maybe a jelly donut where it gets flat in the middle, but it's still connected. I don't know. And then you could multiply by 2 to get both, right? You could go from 0 to 1 and then multiply by 2. All right, so in this case, we just have this region. It's being rotated around the y-axis. Since we have a vertical axis, guys, since we have a vertical axis, we're going to do a vertical rectangle. So it's a distance of x away. That's what always helps me know if I'm going to use x or y. I don't usually think about the disk method, and that's the opposite. All right, my height of my rectangle is the top curve minus the bottom curve. Our bottom curve is just 0, so it's just x minus x cubed. So my volume is going to be 2 pi, 0 to 1, radius times height, dx. And I think you guys got 14 over 5 pi, is that right? Yep, so that's your answer. Okay, so let's try some where they are not around the x-axis or y-axis. So in this case, we're going around the line x equals -2. Oh yeah, you need to go back. Yep, right there. 4 pi over 15. Okay, thanks. You guys didn't correct me. 4 pi over 15.
That makes a lot more sense.
Okay. All right, so we have the region bounded by 8x minus 2x squared and 4x minus x squared. So which one's the top curve, which one's the bottom? Any ideas? 8x is the top one. You guys can plug in numbers if you need to. If you plug in like 1, so here's where 1 is. That would help you find which one's the top if you need to do that. So the 8x one is the top. Okay, so we need a vertical rectangle that we're going to draw in. And it's going all the way around this x equals -2. Okay, I can't really think about what the shape is. I don't know. Like a giant ring. That's kind of funny shaped. Yeah. I don't know. It's weird. Because you have a big space in the middle that's empty. All right, so now we need to talk about the distance from our axis of rotation to that curve. Now from here to here it's just x. So you can think of it that way. And then from here to here it is 2. So it should be x plus 2. But I still think the easiest way to think of these is right minus left. That distance is right minus left. It's x, right? This would be x minus a -2. So your radius is x plus 2. So you do right minus left. So you abbreviate left.
If you subtract the first, that's just like
We're not to the height yet.
Yeah, that was my comment.
All right, our height is top. So I said the top one was the 8x minus x squared minus the bottom.
So it's a 2x squared.
Oh, minus 2x squared. Okay, thank you. Okay, so when you simplify that, you get 8x minus 4x, so 4x, -2x minus a -x squared, so -2x plus x squared is -x squared. Okay, so our volume is going to be 2 pi. I'll put the 2 pi on the outside. My x values are just the x values of the intersecting curves, right? So the x values are 0 to 4. This is 4 right here. That's the only thing that's creating volume. Does that make sense? All right, and it's 2 pi. Radius is x plus 2. Height is 4x minus x squared.
So is it x plus 2 for both of them?
What do you mean for both of them? There's no outer and inner radius on these because the shell is created by individual rectangles that are whipping around the axis and creating, remember that woodcut thing I showed you? So that's one radius that's created. You have one cylinder that's created. So there's no outer and inner on this one. So that's nice on this because you never have to worry about that. You never have to worry about what's outer, what's inner. All right, did you guys do this one? 56 pi over 3, is that what you said? 256 pi over 3. Is that right?
How did you get x plus 2?
Because you're talking about the distance from your rectangle that you drew in to the axis of rotation. So wherever you drew this rectangle, that's x away from the y-axis, right? That's x. My x is very sloppy. And then that axis is 2 away from the y-axis. So it's x plus 2. Think of it that way. Or you do right minus left. Your right would be x. Right, this is x minus a negative 2. Okay. Let's try one more. Okay, so find the volume of the solid revolution formed by revolving the region bounded by x squared minus y squared equals 7 and x equals 4 around the line y equals 5. Okay, so around y equals 5. So that's this line. X equals 4. So we end up with like this shape here. Oh wait, hang on. X equals 4 and can't tell what my lines are. X equals 4 is the one, this one. Yeah, so right here. Yeah, so that little piece there. Okay. So how do I draw my rectangle? Think about the shells that are being created, right? It needs to be horizontally, right? So draw it wherever you want, horizontally. Okay, I didn't draw it on the axis because I didn't want you guys to think the radius was 5. Kind of drew it a little bit above. Doesn't matter where you draw it. You could draw it below. Doesn't matter. Okay, that is some particular y value. So that height right there is y. So my distance from the axis to that rectangle is what? 5 minus y. Right? If y was negative, does that still make sense? If y was negative 1, it'd be below. So it'd be down here. 5 minus a negative 1 is 6, right? That'd be 6 away. So it makes sense. All right, so that's our radius. Our height, how do I do that? Right minus left. And we need y's, right? So I'm going to solve for x up here. So I'm going to have 7 plus y squared equals x squared. So x equals plus or minus the square root of 7 plus y squared. Now that's representing these two curves. Okay, so what one do we have? Right, the positive one. The x values are positive. So it's the right is x equals 4, so 4 minus the square root of 7 plus y squared. So our volume is going to be 2 pi. Y values, what do they go from? Can we tell? Negative 3 to 3. Does work out nice on yours? Negative 3 to 3. All right, and then you can just tell from your graph. 3 to negative 3. I drew mine kind of sloppy. All right, if you guys didn't know where those were, then you'd have to actually plug in x equals 4 to this original equation or to this equation, doesn't matter, and solve. Okay, and then we're going to go from our radius is 5 minus y. Our height is 4 minus the square root of 7 plus y squared dy. Now you could go from 0 to 3 and double it. Could you? No, I don't think you could. So why could you not go from 0 to 3 and double it? I don't think it does create the same volume. Because this, think about it, if you're rotating it around, guys, think about this visually. If you're going from 0 to 3, that is a smaller donut that's created than from negative 3 to 0. So you can't just double it. So you can't go from 0 to 3. Yeah, if it goes further, so it has to have a bigger volume. All right, so go ahead and find it. I hear Allie typing away. Yeah?
It's right minus left. Isn't our right line
X equals 4.
4 minus 4? Does that help?
The right line was this, x equals 4. The left line was this.
Right, so that's how we just got 4 minus 7 plus 1.
Yep.
Because the 4 minus 4 would cancel.
What's the 4 minus 4?
Isn't that when we do right minus left, it's 4 minus and then whatever your right line is. And then your left line is 4 minus 7 plus.
In this case, you're actually attached to the. So, did you guys see what Catherine's asking? She's saying, shouldn't you have like 4 minus square root of 7 plus y squared? Because you're going around the line x equals 4. But it's actually attached to the axis. The ones you're talking about, Catherine, are when like your axis was like over here. So like x equals 7. That would be, you'd have to do, I don't know, that's kind of weird. Yeah, so then you'd have like an outer and inner radius, but we don't, and you won't see that on shell method. Yeah?
How do you know it's a positive square root of 7 plus?
Because x values are positive on this side of the graph. They're negative over here, right? So x equals negative a square root. So you can plug things in. If you want to plug in 0, you'd get positive square root of 7. Okay, positive square root of 7 is here on this side, right here. It's not this side. That would be negative square root of 7. Waiting for the light bulb. You get it? Okay. All right. So is this making sense? Do you guys feel comfortable with shell method?